Howdy folks, good evening. It's late now. I want to explain something more about the quantum mechanical happenings that are going on in a two-slit experiment. What's happening over there? What is the quantum collapse? Quantum, and then the function wave function collapse. Well, you got two types of stuff. You got macroscopic objects, MOs, and wave functions, WFs. The best quantum mechanical properties are visible in if a particle is single, is free to move. Then it behaves like a real wave, as we know. When it interacts with a macroscopic object, MO, then actually we have to look at the MO about what it consists of. An MO consists of a lot of wave functions, individual wave functions of electrons, of protons, of neutrons, etc., and photons, etc. So, well, if you have a single wave function of a photon or an electron, and it approaches the screen, detector screen, what it does, it's approaching, the wave function is approaching that screen, and but also the wall, the screen where it is about to be hit, is consisting of wave functions of electrons and etc. that are bouncing around and around in the atoms. And if you look at the screen, then you get a certain pattern where you get it like a two-slit experiment is known. But what happens is actually that the two wave functions, the individual wave function, interacts with one of the wave functions of all those billions and trillions electrons, because let's assume it's a photon, the wave function of a photon that is interacting with the wave function of an electron. And what happens, if you look at the interaction itself, the photon is absorbed by some electron. And so it's entering an energy well. And but that is in a bound state. So it's more bound, the photon is more bound in an energy well than it was previous. So what happens, and why this electron, not the other ones? Well, at that moment that the photon, the wave function of the photon was approaching the screen, at that moment that electron's wave function was the closest by to interact with the photon. I mean, you have the wave function all over the place, all over the screen, approaching to it with ups and downs, of course, as we know them from the wave functions, as we see them on the screen, with the up and down patterns. That pattern, what you see in a typical two-slit experiment. But at the moment of approaching that wave function and the wave function of the electron are the first ones to touch and to interact, so to say. And that can be here, it can be there, it can be there, it can be somewhere else, that can be in that pattern that we see. But at that moment, when it interacts, it's that photon interacts on that spot, because the wave function of the electron happens to be at the same point as the wave function of the photon, and the photon gets grabbed into the energy well of at that moment, at that spot. So what happens is that the wave function merges with the wave function of the electron and enters an energy well. So it becomes more localized, and from our perspective, it's totally random, then if you do one photon per time throwing at the two slits, then you see it being at the screen. You see building up kind of randomly in those patterns, but kind of randomly. But that is just for our perspective randomly in that pattern. But when it seems to collapse, it's actually being put in an energy well, so that it gets confined more, and it's becoming part of the macroscopic object. In this case, the screen, the detection screen. And so it becomes part of the macroscopic object and interacting with it. And so it appears that it's a wave function collapse, but what happens is that the wave function is not collapsing. There's still a wave function of that photon, but it's more confined into the energy well at that location, in that area, in that atom, with that electron. And because if we look at the quantum tunneling effect, the wave function outside of that area of the photon is still present, but it's reduced to be more localized in the atom at that moment. But since the location is more precise than the speed, the location is more determined. So the rest will the speed is zero. It doesn't move, at least not as it used to move. The Heisenberg principle. And it has become part of the macroscopic object. So it seems as though the wave function is collapsing, but it's not collapsing. It just happens to interact with the first option that became available, because the wave function of the electron was at the same place as the wave function of the photon that arrived, or electron, or whatever kind of particle. Well, this is what I want to share. And what is also kind of funny, and we have to remember, is that at the moment that a wave particle is created, supposedly, for example, in a laser, and it leaves the source of the light, it must be entangled to that source too, according to the entangulation principles. It needs to be entangled with that apparatus too. So, and that's very interesting, that everything seems to be entangled. The source is entangled with the photon it created. Well, this is what I want to share for a moment. Okay, yeah, well, this is it actually. Okay, that's all the best.